Today's lesson is about graphing quadratic functions. We're going to use a table of values to graph a quadratic function and then analyze the graph. We're going to learn a lot of new vocabulary today, so it's important that you pay attention. And on the bottom here are just some of the Common Core standards that this particular lesson addresses. So quadratic functions are non-linear functions, which means that they are not lines and they pass the vertical line test, and you have to remember that from long ago. They're written as f of x equals ax squared plus bx plus c. Remember, f of x is the same thing as y, where a does not equal 0. And the reason why a cannot equal 0 is because then we would just have bx plus c, which is a linear equation, and we want something with a squared term because that's what makes it a quadratic. When we graph a quadratic, its shape is a parabola, and this is a U-shaped figure, and it opens up or it opens down. So here you see that this is in graph 1, this is a parabola that is opening up, which means it looks like a regular U. And in graph number 2, this is a parabola that is opening downward. And the reason or the way that you can figure out if the graph is going to be opening upwards or opening downwards is because this value of a here will be positive or negative. So when it is positive a, you will have a U shape opening up, and when it is negative, it will open downwards. So I always think that positive, this kind of looks like a smiley face. It's somebody's smile, and negative is frowning. It's an upside down, so if we were to give it some eyes there, it's frowning. Okay, here's some eyes there to help you remember. Positive looks happy, negative looks sad, and positive is a positive value in front of the x squared term. Negative has a negative value in front of the x squared term. So here, there's nothing special with using a table. We're just going to use our graphing calculator and take a look at the table of values. So here it says use a table of values to graph y equals 3x squared plus 6x minus 4. Remember, when you type this into your TI Nspire calculator, you're not going to write the y equals part. You're just going to write the 3x squared plus 6x minus 4. You're going to hit Control T to look at your table, and notice, you might say, well, how do I know where really to start graphing? Your y values, or your f of x values, you want to pick them so that there is a particular pattern. So notice that I have a positive 5 here and a positive 5 there, a negative 4 here and a negative 4 there. So far it's the same numbers. And then I have a negative 7. And there's always going to be one number or one coordinate, and then after that the numbers will start to be a mirror image of one another, at least in the y values. We don't particularly care for the x values in terms of this pattern. We always just look for the y values because that's going to give us that U shape when we graph. So if I were to graph this, my first point is negative 3, 5, so negative 3, 5. And then we've got negative 2, negative 4, so that's all the way down here. Then we have negative 1, negative 7. There we go. 0, negative 4, and 1, positive 5. So you can see if I were to connect this, now I can connect this curve because I was taking a table of values from myself. Now this is a little bit harder on an iPad, but there is my U-shaped parabola because my 3, which was in front of the x squared, was positive. This was a parabola that opens upward. And that is how you graph a parabola. You just pick a table of values. When you're on the Regents exam, you always want to write down your table of values so that the rater can understand where you graphed this from. And then you just graph and make sure you label y equals 3x squared plus 6x minus 4. So here I just got us a better picture of this parabola, since it's a little bit harder for me to really draw it with the stylus on the iPad. So here's a better picture of that same graph that we just graphed together on the previous image. We want to state the domain and range, so that was part of the directions. Remember, the domain is all the x values and the range is the y values. The domain, if you're looking here, we don't have any particular, if you were to scroll back in that table on your graphing calculator, if you were able to follow along, we can take any x value that we want. So we can say that the domain is all real numbers, and then the range, well, the y values are always moving upwards, but they can't be below this guy right here. We don't obviously have anything down here in our graph, so y has to be greater than or equal to 7, and that's how we would write our range here. Now, I would like to, I'm just going to spend some time erasing what we've got here, only because we have some really important things to talk about in terms of the graph itself. We have some new vocabulary. The first is going to be the minimum value. So whenever your graph opens upward, you have a minimum value, which is always just the lowest point on your graph. That lowest point is called, or if we look at our graph, is this guy right here, -1, -7. That is our minimum, but it is also called the vertex of our parabola. So it's an important vocabulary word. And if we were to take this parabola and fold it in half, it would be a mirror image. It's a mirror image of itself. Now the line that we can fold it in half on goes right through that vertex. And the line, since it's a straight up and down line, it's a vertical line, it is going to be an x equals equation, and it's actually just going to be the x value of your vertex. So -1 is the x value of my vertex. So this is actually called my axis of symmetry. And it's basically the line which the parabola can be folded around so that it folds directly onto itself. It makes an exact copy of itself when folded. So think about symmetrical. If you cut a butterfly in half, it will be exactly the same on either side. Same thing with the parabola. So some of our new vocabulary words so far are minimum, vertex, and axis of symmetry. Okay. The other thing that you might be asked about a particular parabola is where's the y-intercept, and that's something that we know already. The y-intercept is just where it crosses the y-axis, and you can always look at that in your image, but it's also helpful to know that this last value here in the equation always tells us where it crosses the y-axis, and if you notice here, it crosses right at -4. Okay. So here's one more example. If we were to graph this one, -3x squared plus 6x minus 5, you'll notice that because there is a negative value in front of the x squared, this is going to be a parabola that opens downward. We're going to take a minute to graph. Here we have -1, -14, 0, -5, 1, -2, and then you see the numbers start to repeat themselves, the -5 and -5, the -14 and -14. Now again, you would just take these values and you would plot them on your coordinate grid. And now I'm going to move to the next slide since I don't have a -14 or a +14 on my coordinate grid. I'm going to move just to the next slide to show you what the graph would look like. So here's the graph in your TI Nspire calculator. What's nice is we have some grid lines to take a look at, but some more vocabulary we need to worry about. Well, this time the graph opens downward, so there is no lowest point. There is no minimum value. Instead, there's a maximum. Now remember, the maximum is the highest point on our graph, which is right here, which also happens to be our vertex. And our vertex has the coordinates 1, -2 based on our graph. Our vertex is the point that passes through the line of symmetry, or the axis of symmetry, which is, axis, sorry, gotta erase that. Axis of symmetry, which is the line that goes directly through the center of the parabola, and remember that line goes right through our vertex, so that line is this vertical line right here. And remember, vertical lines are always an x equals equation. And it crosses through the x value of the vertex, which is +1. So that is our axis of symmetry. The last thing we need to remember is the y-intercept. We can get that from looking at the graph. It crosses right here, but we can also take it from our equation. That last number in our quadratic equation is the y-intercept. Okay, so here's just a recap, some important vocabulary you need to remember. Maximum and minimum. Remember, you have a minimum value when the parabola opens downward. You'll have a maximum value, upward, and a maximum value when the parabola opens downward. The vertex is the maximum or the minimum. The axis of symmetry crosses through the vertex. We didn't talk about roots and zeros, however, these are the x-intercepts. And we'll talk more about identifying those in class tomorrow. And y-intercept, we obviously know, is where the graph crosses the y-axis. Okay, and so remember the roots and zeros, something we talked about when we were dealing with linear equations. We just talked a little bit about that vocabulary, also known as the x-intercepts. And we're going to talk about how all of this, particularly the roots or the zeros of the function, relates to how we've been factoring and solving quadratic equations. Okay, remember to fill out the Google form. You'll want to replay this video and study what these terms mean because they're extremely important. And you might have some questions on the Google form about them. Have a good night.